Hello, today we will be talking about how to run a container on an HPC system. This is going to be a quick video, which is by all means not exhaustive, but it will hopefully get you going enough that you can get up and running with your first container on Lakeshore. The version of the container runtime that we support on Lakeshore is called Apptainer. Apptainer allows you to run a container as an unprivileged user in user space, meaning that you can run this in your home directory or project space. In order to load Apptainer in your environment, you will first need to start a job on a compute node. In this case, we're going to start a very basic interactive job on the batch partition. Once we have started a job on the batch partition, we can now use the module command to list which versions of Apptainer we have available in our environment. And then load it. Now that Apptainer is loaded in our environment, we can run it and pull down our first container. By default, Apptainer will cache containers in your home directory. Depending on the container that you pull down, they can be rather large. So what you can do is redirect your container temporary files to another location. On a compute node, there are various Scratch directories that can be used. Scratch Network is a temporary location where you can store large temporary files while you work that get purged occasionally. We also set up a local Scratch directory on the compute node hard disk itself. Once a job finishes, this directory will be purged. By running export Apptainer cache directory, we can redirect where the cached containers are downloaded. Now, let's pull down our first container. Lakeshore is running a version of Linux called Rocky Linux. But let's say we wanted to run a different version of Linux. We had an application that ran in Ubuntu. So let's pull down a Ubuntu container from a Docker registry. We'll run the command apptainer pull docker Ubuntu, and then this is the tag. We will be pulling down version 20.04. This will connect to the Docker registry, pull down the container, and then convert it from a Docker container to a format that is native to Apptainer. If you've worked with Docker, Docker stores containers in a registry. Apptainer stores container images in a file local on your disk with a .cif extension. We now have an Ubuntu 20.04 CIF container image in our home directory. We can take this image and run it here, or we could copy it to another machine and run it and have the same working environment. By default, these containers are rather small. This one is 27 megs. There's not a lot of software available inside of these. So typically these containers for Linux distributions are often used to bootstrap and build larger applications. Let's take a quick look at running a command within a container. We are on a compute node. If we take a look and check the version of the operating system we're running, we see that it's currently Rocky Linux 9.2. Using the command apptainer exec, we're saying that we are going to execute a command within the apptainer image, and we're going to run the same command to check the version of the operating system we are running. We now see that our response is Ubuntu 20.04. Since this is a bare bones container, there is not a whole lot we can do with it. However, we can create our own container based off of this. On Lakeshore and often on most HPC systems, you will need to have administrative rights to build a new container image. So what you can do is install Apptainer on your own machine, or you can provide us with a definition file and we can assist you with building a new container if you would like. Let's take a quick look at an example of a definition file. This is a very basic definition file. In this case, I'm going to bootstrap from Docker. I'm going to pull down the same container, Ubuntu 20.04, and then I'm going to run a system update. And in this case, I'm just going to install Python 3. Over on a separate machine, which is still in our HPC environment, where I have administrative rights, I'm going to run Apptainer build CIF. This is the resulting container image that I'm going to build and provide the definition file. We now see that has pulled down Python 3, has been installed, and is now creating our image file. Now that's completed, we have the resulting Python image. So taking a quick look at it, if I check the version of Python on my current machine, I see that it's 3.9.16. If I run the same command inside of my container, oops, we can see that I have a slightly older version of Python. This is the default that gets pulled down in Ubuntu 20.04. Now let's see what this looks like in practice. I can run I can run Apptainer exec, give it my image file, and then I'm going to invoke a very basic Python command. I'm going to load date and time and then print the date. So I am in my home directory on Lakeshore, but I was able to execute this Python code within the container. Building on that, if we run Apptainer shell Python CIF, we see that my prompt has changed. I am now inside of the container. We can check the version of the operating system I'm working in. I'm running in Ubuntu 20.04. But I can still reach all of the data in the underlying operating system. By default, many of the software paths that you would expect are available bind mounted into the containers by default. So we can still reach our project folders or software directory and other things within the underlying operating system from inside of the container. If I exit the container and export an environment variable, we can actually see that this will follow us into our container environment. So working inside of the container environment, we can still reach many of the underlying file systems that we would typically reach outside of the container. Our environment follows us inside of the container. However, if we wanted to have a cleaner environment where environment variables and mounted file systems do not follow us into the container, we can add a couple of different options. Running clean env would make it so that environment variables such as the one that we set would not follow us inside the container. As well, running something like contain all would now give us, we are still in my home directory, but this is emptied and I do not see my files here. I also see that software directory is not available to me. Beyond that, what we can do, if we wanted to run a container on a GPU, we can do so. In this case, I'm going to start a new job on the batch GPU partition. I'm going to request one small GPU. Now, if I give it the --NV option, this tells Apptainer to pass through the GPU that I have reserved for my job into the container environment. By default on Lakeshore, we set this on all GPU-enabled compute nodes, so you do not need to set it. However, it's worth taking note. So now if I run inside my container, NVIDIA SMI, we can see that it is able to see the GPU which is assigned to us for this job. Putting this together in a submit script, in this case, we're going to ask for one node, one task, one CPU for the task, and we're going to submit with my account to the batch partition. I'm going to load Apptainer, and then I'm just going to run a very basic command that I ran earlier to print the date. Now that's been submitted. You can see this is my output.